introduction to motion, and we're going to introduce a couple of concepts today. Particularly, we are going to look at the concepts of position, distance, and displacement. So we're looking right now, we're looking at one-dimensional motion. So what we're going to do is we're going to go through those concepts one at a time just to introduce the idea. Okay, so what does one-dimensional motion mean? It means motion in a line. You're either going one way or the other way, positively or negatively if you want to call it that way, but there's only one direction of motion. So when we're going to define these concepts, position, distance, and displacement, let's start with position. Because in order to define motion, we have to describe where an object is at any time. That's what we mean by position. So position we're going to give in one dimension, we're going to give it the variable x. It's a description of where an object is located. Now, in order to determine where something is, you need some sort of reference grid. And so what we would use is a coordinate system. And a one-dimensional coordinate system is simply a line. So if you look below, you can see here's a one-dimensional coordinate system, and each of these are a unit along the coordinate system. And if I were to pick a position, I would say, let's say right here, x equal to 2. Over here, x equal to -6. So I'm going to look at a change in position in one dimension. I'm going to go from one point to another point, and that's going to give me basically how far I've moved during that motion. Okay? So just for your, if we end up, when we move on, if we end up moving on to two-dimensional motion in honors physics, yes, we will. The coordinate system now is an x-axis and a y-axis, and a point on an xy graph, for example, point right here would be x equal to 3, y equal to 2. And sometimes we might call the generalized point in 2 dimensions r, or in 3 dimensions. We won't worry about 3 dimensions right now, but if you can understand 2-dimensional motion, 3-dimensional motion is actually not that hard. All right, and this is what a 3-dimensional coordinate system would look like. You have an x-axis, a y-axis, and a z-axis. And this point right here would be 3x equal 3, y equal to, x equal to 3 this way, y equal 4 this way, and z equal to 5, although it's a little hard to see that it's really parallel to that point right there. Okay? Now, distance and displacement are two very similar concepts. They both measure a length. For example, it could be a length in meters, in feet, in miles, in light years. But the difference is important, because distance really is just the total length you traveled during a motion. Direction doesn't matter. So if I go from point A to point B, and I take if a direct line from point A to point B was, say, 2 miles, but I take a long, out-of-the-way trip to get there, and I end up covering, let's say 2 miles south and 2 miles east and 2 miles north, I end up 2 miles from where I started, but my distance was 6 miles. Now, displacement's a little different. Displacement is defined specifically as the change in position between your initial point and your final point. So I call it x final minus x initial in one dimension, or delta x. Displacement is a vector quantity. What does that mean? It means it has a direction as well as a magnitude. So in one dimension, displacement is going to be either positive or negative. You're either going to the right on your axis or going to the left. We usually call to the right positive and to the left negative, though it's not required. So if I just look at a car right here, if I move from point A to point B, I start at point 30, I go to x equal to 53. In this case, my distance is 52, I guess. My distance is 22 meters. And my displacement is also 22 meters, but I'd have to say 22 meters to the right. Now, if in this case I go from point C to point F, my distance is going to be, I started at 38, I end up at minus 53, and so I'm going to go negative in displacement. I'm going to go negative 91 meters. In distance, I'm going to go 91 meters. Now, let me go back. So, again, I guess here's reiterating. If I go from 30 to 52, my displacement is positive 22 meters, like we just said. My distance and my displacement will be the same number if there's no change in direction. If there's a change in direction, the numerical value will be different. Now, if I go from C to F, I go from x final is negative 53 minus x initial is 38 meters. So I've gone a displacement of negative 91 meters. My distance is 91 meters, but the direction doesn't matter. Okay, so let's look at the graph below, and let's look at the distance from the beginning to each of the points shown from the beginning and the displacement from the beginning to each point, and we'll contrast the difference. So here, what I've got is I've got a position versus time graph. What this does basically is it tells me at any time where I am. So at 0 seconds, I start at 30 meters. At 10 seconds, I'm at about 52 meters. At 20 seconds, I'm at 38 meters, etc. So this is the whole trip that we just showed in the previous slide. And what we can see is that we go forward and then backward. Basically, the motion would be forward and backward, and the graph is stretched out because time is each point is a later point in time. And then for each point, from A to B, A to C, A to D, A to E, A to F, we can figure out the distance and displacement for each of those points. So the distance from point A to point A is 0. The distance to point B is going to be positive. This is the displacement, sorry. Yeah, at point B, the distance is, distance and displacement, right. So at point B, from point A to point B, you traveled 22 meters in distance, and your displacement is positive 22 meters. From point A to point C, your distance is 36 meters, but since you've turned around, your x final minus your x initial is only 8 meters. You're only 8 meters positive from where you started. You can always go back on the graph and check to make sure that that makes sense. At point D, you continue to add on distance. Now you've gone 74 meters, but you're now 30 meters to the negative of where you started, so your displacement is negative 30 meters, etc. So you can check the last two and see that those also work. So, that is a brief introduction to the concepts of position, distance, and displacement. In our next recording, we will talk about the difference and similarity between speed and velocity, because we're not just going to talk about where you went, but the rate at which you went there. All right, that's it for our first video on motion.